Do you know that atoms have their own distinct vibrations? It's fascinating, and it's a property so essential to nature's building components that a group of University of Washington researchers recently observed and incorporated it in their research study. They were able to identify vibrations known as atomic breathing by monitoring the light atoms released when stimulated by a laser. As a result, we've made a breakthrough that may one day allow us to create better tools for future quantum technologies. Hello and welcome back to Quantumfy. In today's video, we'll see living, breathing atoms, the next big discovery in quantum technology. So let's get started. Scientists at the University of Washington have discovered a new way to control the quantum state of atoms. By measuring the mechanical vibration between two layers of atoms, known as atomic breathing, they can encode and transmit quantum information. This breakthrough could lead to new developments in quantum technologies, such as quantum computers and quantum communication systems. These quantum communication systems use quantum entanglement to transmit information securely over long distances. The researchers used a device called an atomic force microscope to detect atomic breathing. The atomic force microscope uses a sharp tip to scan the surface of a material. When the tip is brought close to the surface, it creates a force that causes the atoms in the material to vibrate. This research was led by Mo Lee. He's a professor of photonics and nano devices at UW. The researchers were able to use the atomic force microscope to measure the frequency of the atomic breathing, which is directly related to the energy of the quantum information that is being encoded. Ruoming Peng, the lead author of the paper, is excited about the new realm of possibilities. The ability to control atomic breathing could be used to create new types of quantum devices. For example, a quantum computer could use atomic breathing to store and process quantum information. A quantum communication system could use atomic breathing to transmit quantum information over long distances. The researchers were able to encode and transmit quantum information between two layers of atoms. They did this by using a laser to excite the atoms in one layer. This caused the atoms to vibrate, which in turn caused the atoms in the other layer to vibrate. The researchers were able to measure the frequency of the atomic breathing in the second layer, and they were able to use this information to decode the quantum information that had been encoded in the first layer. Adina Rippin, another lead author within the paper, puts emphasis on photons and their ability to travel long distance without loss of energy and information. In addition to the potential applications in quantum technologies, this work could also have implications for other areas of science and engineering. For example, it could be used in study of the dynamics of materials at the atomic level, or to develop new sensors for detecting and measuring physical phenomena. So, this was it for today, guys. Hope you enjoyed our video. If you did, then like and share the video and subscribe to get quantified. Stay tuned as we'll be back soon with another informative video. Till then, keep watching Quantumfy.